My name is Sachin Pargi. I am a senior principal architect at OpenText. I work in the AI/ML division there. Today I have with me Avadhoot. He's director of software engineering. He'll help me in the questions. So let's start. So the title of the talk is Enhancing Threat Intelligence Using AI, right? As you guys know, cybersecurity is a vast world, right? The threat intelligence is one aspect of cybersecurity. So what I'm going to do in this talk is give a little bit introduction of cybersecurity as it relates to threat detection and how we have used AI to solve some of the problems. And this is completely developed in India, conceptualized in India. And we have many more use cases that we want to develop in the future. So let's start. Cybersecurity introduces lots, has a lot of gamuts, right? But when it comes to just the threat detection, imagine what you guys do day to day, right? When we're in cyberspace, we either visit a website or download a file or looking at an URL, right? Looking at the contents of the URL. So it is our duty to protect that users, whatever users are doing, are to detect that the URLs are good, right? The files that is downloading is good and bad, right? That's what we do at OpenText. Right, so as you guys know, cyber threat, the detection is measured in hours today, right? Not in minutes. So at OpenText, we have a slew of products from detection, prevention, recover, and investigate. This is the NIST framework, and all of this is powered with ML Foundation. Now, total security is a myth, right? We can't say that we can reduce the threats to zero. If any company is claiming that the threats will go down to zero, they are either lying, right? So at OpenText, we believe that we want to reduce the risk arising out of threats, minimize the disruption that the threats can cause. At the same time, if we're not able to detect and prevent, at least recover the user to a well-known state, right? So we have products in every area and which is powered by ML. So what are the challenges that we are seeing, that our SOCs are seeing every day, right? So I want to introduce the concept of SOC here, right? So when you talk about endpoint detection and prevention, right? Your day-to-day endpoints are monitored by an SOC, right? SOC stands for Security Operations Center Analyst. Today, they are faced with multiple challenges, right? So they have, one of the biggest challenges, they are overrun with lots of data, right? And they have challenge in shifting what is right, what is not right, right? What is good, what is bad. They use a lot of tools. They connect a lot of data sources to quickly conduct investigations. And it takes time today. And they have to correlate this data and complete investigations. As I said, the metric is in hours, not minutes, right? And they have to develop context because they need to report these incidents to higher management or even to the customers. And the last but not least is the challenge of false positives. So at OpenText, we took it as a challenge and see how we can effectively apply AI, right, to improve, to basically help the SOCs in, may not be all of this, but some of this, right? I'll explain how we did that. And the important things, the metrics, right, in the SOC world is MTD, MTTD, and MTTR. This is mean time to detection and mean time to detection. Not only we detect it, but we also provide recommendations, right, on the same platform. So this is the use case that we went about and solving it. The challenge to us is that the security analysts today manually analyze large amounts of data, right, from various sources. And they need to execute complex workflows, and they don't know what workflows to execute at what time. They have alert fatigue because there are lots of things that they need to look at. and they need to provide response back to the higher management and customers, which causes delayed response time. So what we went about and developed is a conversational AI assistant, which can help them. And what are the solutions that we came up with? Some smart alert summarization, prioritization, anomaly detection, context analysis. So these are all done automatically by our GenAI platform. So I have an architecture coming up, which explains how we went and did that. So what are the benefits of doing this? Increased efficiency, better incident response, improved threat detection, and faster detection and making, right? So before I delve into the GenAI architecture, I want to take a little bit of time to explain you the threat intelligence platform that we currently have, right? So this is an integrated threat platform that we have, which means to say that the data collection, data ingestion, data processing, building the machine learning models, right? Everything happens on the same platform. So starting from the bottom of the stack, right? So we have data sources, various data sources. Number one is we have crawlers running every day, which collect the data from the internet. That means to say anything that gets created, any new URL gets created, new IP gets created, or domain gets deleted, right? We come to know within minutes. So we have crawlers running 24/7. We also get data from our endpoints. So we have around 70 million endpoints that are running today in the field, and that provides us the source of data, right? So once we have the data, we ingest the data into the same platform, and we do the processing of that. When we say processing, we have to correlate the data that we have, right? And we do maintain this relationship between what IPs are related to what files, right? As I said in the beginning, we want to protect users from bad files, executing bad files or downloading files, right? So we go and collect this contextual analysis of this file was appeared on this IP, which belongs to this domain, right? And we have the timeline maintained. In fact, we have, I think it's in the next slide, today in our database, we have around 100 billion URLs, 1 billion IPs, and around 750 million domains, right, for which we have correlation. So everything that happens on the internet, right, we get to know and we create these correlations as part of this layer. Once we do this, right, we also build some machine learning models, which we provide to our customers. We know that customers want to consume this in various ways, right? Some customers may want to call APIs to consume this intelligence. Some customers want an offline builds. So as soon as we do this processing, we build it daily. We have the builds, we give it to our customers, and the models also get updated every week. We have around hundreds of models, both classification and clustering models that gets created as part of this processing, right? So the management, and for the offline builds, many customers, they want to have different organizations have different policies, right? Some may want to block some sites, right? So it's up to the customers that do it. So we provide all this as part of one integrated platform. So we also have an embedded threat intelligence. What that means is that our SOC also log into the same platform. So wherever the data is ingested, SOCs are also on the same platform. So what is the net effect of having this platform is that we consume the data from our endpoints. We also improve it to protect our endpoints, but also improve the platform, right? So the data is used in various ways. We process the data, we improve the platform, we improve our products, and we also provide intelligence services to our customers. So this is another way of actually representing that. We have a cloud-native infrastructure where we have nodes which do all this data processing, data ingestion. We collect the data, as I was talking about, different types of data. We do the processing. And the biggest benefit that we have is we have lots of partners who are ready to work with that. And we have around 750 million endpoints, as I said, right? So where we get the rich set of data. And I think I covered about the discovery, right? So anything that gets created on the internet, we get to know within 5 minutes, and we go and do the builds and make it available to our customers. So coming to the main part of this talk, right? Typically, how GenAI is used in cybersecurity domain, right? There are 4 parts to it: investigation, data analysis, reporting, and response. Now, we talked about the challenges that the SOCs have, right? So they need to collect the data. Today, right, they use a lot of tools. They collect data from different sources. They have lots of data to process. There are a lot of false positives, right? So all this is done whenever data is available, right? The pattern recognition or the knowledge integration and contextual is done automatically by our GenAI platform. In the industry, it's still evolving, right? Not many companies are actually using the GenAI in their cybersecurity space. The investigation involves maybe the basic analysis, right? Okay, the alert is raised. They want to know, okay, what type of alert it is, right? Is it a phishing alert? Is it a malware alert, right? Or they can go deep into it, right? The data analysis part. They may ask, okay, this is a malware alert, but where did it originate from, right? Did it originate from this IP, this domain? And if it is, is it vulnerable, right? How many companies are affected? So they can do deep analysis, right, on that data. So we are collecting and representing the data, right, which enables our SOCs to conduct deep analysis. And then the reporting also is made automatic, right? Once they ask a series of questions, they do the analysis, they can say, summarize this, right, for me. And the reporting is generated, and they can send an email, right, in whatever format that you want to send it. And then they can also auto-remediate from the same environment, right? Because we have this contextual understanding of when this threat is raised, these are the causes, right? And how to go and remediate it, right? So the benefit of using the GenAI is that we have increased detection accuracy and reduced investigation time. So this is our architecture looks like, right? So so GenAI is the buzzword nowadays, right? But I would say that lot of things depends on the use case that you're solving. I'll not talk about LLMs and agents much, right? Being an architect, I want to focus on what kind of data that you have, right? As I was saying, we have a lot of rich data that we have today. So one of the things that we went and did, right, immediately is how do we represent this data so that our SOCs can ask relevant questions, right? So there are investigation tasks and there is deep analysis tasks, right? Investigation could be a question answers, right? Tell me what this alert is. But there could be investigations, right? That means to say that there could be associations, right? They may ask questions, complex questions. So the first thing that we did was go and create associations of this, right? So we went and used the graph database to create those associations. For example, associations could be that this IP is associated with this domain, right? This process was executed on a specific host, right? And this process traveled through the network and reached this host, right? These kind of associations we maintain as part of that. There could be other questions like, okay, I have reached this alert, I have reached the next alert, I have got this alert. Is there any similarity between the alerts, right? That means to say we can use vector databases, right? Vector database allows us to do those kind of mappings. So vector database also. Now, we are not just developing a question answering system, right? We are also developing conversational assistant. That means to say we need to store those conversations, right? It could go long. So that means we need to maintain the history, right? So for long-term memory, also for fine-tuning the LLM. So we went ahead and chose what database that we want to use, right? Now, having mapped the data that we have, that we already have into these databases, you need to go and choose an LLM, right? What LLM suits best. And this is for cybersecurity, right? So we know the vocabulary that cybersecurity contains, right? Vocabulary could be threat, vulnerability, risk, right? So which LLM has this vocabulary? That's also important, right? Before you go and choose it. So we applied all these techniques, right? What kind of data we have, what kind of questions that users can ask, right? And what is the problem that we are solving, right? These all decisions went in choosing the right LLM and the right agents. So one is the historical context, right? So the other one is, as you see in the bottom, right? We also have the real-time alerts that are coming in from our endpoints, right? So what we do, we also store the historical alerts. And as soon as they arrive, we establish the context. OK, this alert is raised. We have rich information in the alerts, right? On which IP it was created, on which host. So we quickly map it to the historical database that we have to create the context and keep it, right? So that when the security analysts come and ask those questions, we already have this information, right? So we also map this to the knowledge graphs so that the answering is very fast. The other thing is the framework that we have, right? So we have to choose a framework, right? We have a lot of frameworks that are available today, right? LangGraph, CrewAI, a lot of agentic frameworks, right? Now, we don't want to stop here just at the question answering system, right? We want to go and remediate also in the future. So one of the frameworks that we choose was AutoGen framework, which allows dynamic execution of workflows, right? We talked about the complex workflows, right, that the SOCs have to execute. It's not one workflow they execute, right? There could be a series of workflows, right? In some orders they have to execute based on the problem that they encounter, right? So this AutoGen allows us to execute the workflows once you define it, right, to any order that you want, again, based on the problem. So we have a mapping of if this problem arises, right, what is the workflow sequence we need to execute. So that also went in choosing the right framework. Right, so we have a demo that is coming up, right? So we have a private preview release coming up in September, and a full release will be done in November. We're calling this OT Agentic SOC. This is how the dashboard looks like. So when we release this, this would be a opt-in feature. You just have to opt in by enabling this flag. And we are calling, the OpenText calls the AI services, right? That is the brand name. Aviator is the brand name for all the AI services that OpenText is delivering. So there is an icon there, Aviator icon. So user clicks there. And there's a customary advisory that the responses may be right, wrong, some cases. So as soon as you log in, you see the contextual alerts, right? So if you think about a typical day in life of a SOC, right? The first thing that he comes in the morning, he wants to know what are the top alerts that he has, right? So we show the context automatically that helps him just seeing it, right? What are the alerts that he needs to address at the first time he comes in. And those overviews that you're seeing is AI generated, because when we get an alert, there's a lot of things that we get it, right? This is summarized so that when they read it, they understand it better, right? So, yeah, and they can go ahead and ask recommendations also for, right, these kind of alerts. They can ask summarization questions, right? They can also ask, okay, what is the recommendation for this kind of alert, right? And they could also ask, right, what are the other status of alerts that we have. Yeah. Um, I think one of the things that we missed was also there's a prioritization aspect. So we have status priority of an alert, right? But what we do internally is doing an LLM is create a composite score of these alerts based on priority, status, and risk. And this is a dynamic score that we calculate, right? Based on a weightage. For example, the status of new alerts gets a higher weightage than the status of closed, right? Those are calculated automatically so that when user logs in, he knows what, right, that they need to look at. Yeah. So this is a negative question that we asked, right? Just to test out, right? Yeah. So I want to end with this, right? AI just doesn't mean Gen AI, right? It also is the traditional machine learning that we have. And OpenText has been in this business of AI, providing AI-enabled services since 15 years. So we have a massive infrastructure where we do the machine learning. And there are low-touch systems. So that means everything from data preparation, data loading, right, feature engineering happens automatically. And we have hundreds of classification and clustering models. We just take it on a face value, right? If a file is determined to be a bad, we don't just look at it, right? We also look if it is, sometimes the file may be good, but it may be associated with a bad URL or a bad domain, right? So we do guild-based association models. We do risk scoring. We also enable real-time services, so where the users can call, right? And then the inference happens within right milliseconds. Yeah, so I will leave it there, and we can open it up for questions if you have.
Okay, sure. We can do that. Thanks.
I think we are short of time. We are available if you have any questions, so we can talk.
Thank you.